So what we're going to talk about today is really how we at Juniper embrace the very concept of automation, network automation for the wide area network, right? Specifically covering the IP transport, where this is where we at Juniper really primarily focus on. So over the next 45 minutes, what I want to do, I want to kind of hit the ground, just give you a high level overview on, in the intro, why automation. Then I'm going to just give you an overview of how we do it at Juniper with Paragon. Paragon is the brand and the name of the solution. It's a software solution that really runs on top of the network infrastructure to fully automate, to really fully, give you the capability to go from the classic EMS, NMS functionality, element management systems, network management systems, all the way through the very concept of self-autonomous or self-healing networking. I'm going to then move to practical use cases and just a couple of case studies really for you to understand how we are deploying and how we are really embracing automation today around the globe. And then at the end, hopefully we can leave some time for Q&A and the closing. Okay. So with that said, just moving on. Today we're going to talk about network automation, but primarily it's going to be around the concept of automating the wide area network. So this is primarily the IP transport. And as I'm trying to illustrate here, it's anything that goes from the core, from the IP core on the right side, all the way down to the very axis of the network. So we basically transition across the aggregation and the metro to the edge environments, and overall covering anything that relates to the IP transport. So looking at where we are today from a market perspective when talking about network automation and particularly the journey, today we are still pretty much in the early stages, even if we've been talking and kind of evangelizing the concept of automation. Today, still, we are at the kind of the early stages, pretty much in the kind of what we call semi-automated phase. So if we actually take the journey and we break it down to different stages, we go from what used to be semi-automated tasks, so something that was primarily command line interface driven through scripting and kind of automating some tasks, then moving to something more related to methods of procedures and operational activities that go in more semi-automated, and this time already user interface driven, and all the way down to, or all the way up to the right side of the slide, where really move from automating tasks towards the concept of automating decisions. At this point, this is like an inflection point where when we allow the network really to start automating decisions, this is where we can embrace truly the concept of autonomous networking, and if you wish, self-driving or self-healing networking. So there are obviously quite a few challenges in order to embrace this journey. Today, as I said, we are still pretty much in the early stages, and as you can see on the right side, up to 75% of network activities around the globe, primarily looking at telcos, are still manual. On top of that, we still see that up to 80% or 85%, of the processes, and as I said, things like manual procedures are still CLI or command line interface driven, which means a lot of scripting. It is then not a surprise that if we look at how we are kind of doing automation today in terms of projects, most of them, 70% of them, and this is really according to the industry reports and insights that we're getting, from the aggregated market industry. What we see is that they are not successful. So 70% of projects are yet not successful. And the reason primarily is because it's still very much do it yourself or kind of reinvent the wheel approach, which means a lot of customization. So what we really want to approach or want to brace with Juniper is a way to try to make it out of the box, try to make it simple, and try to make it more programmable as a way to improve this rate right now and make it, more successful. So in order to approach and in order really to embrace this, we need to think about what are the typical and the common use cases when we think about automation. And classically or traditionally, we relate automation to basically improving operational efficiencies, basically improving the OpEx. If you wish, uh, anything that relates to do more with less, right? And how we relate that traditionally with the networking environment is things like, device onboarding, lifecycle management, things like software upgrades, and audit and compliance management and the like. This is kind of typical use cases that we're going to talk about today, but we typically relate more to the traditional dimension of automation. We at Juniper also want to embrace automation to do more, to really go beyond that classical or classic concept, which is really about using automation to improve the output of the network. So basically, to deliver a better user experience to the end customer. And the way we do it with automation is based on the intent-based concept. Only that we at Juniper, we turn the intent-based into the very concept of what we call experience-first networking. So we at Juniper conceived or kind of coined the concept of experience-first a few years ago, 4 or 5 years ago. And again, this is really all about turning the intent-based concept that has been evangelized and has been really discussed quite extensively in the automation context for a while. So what we do is we actually take a more practical or pragmatic approach, and we turn the intent-based, which is more generic, into something more specific, which is experience-first networking. What that means is that we basically drive automation based on how we can improve the output of the network as it is translated into the quality of service and quality of experience of the end user. And how we do this, we use a software, which is the kind of automation suite that we use at Juniper that is called Paragon. And that software that runs on top of any network infrastructure in a multi-vendor fashion, it gets you covered all across the entire lifecycle of any network service. So if we try to illustrate this in this circle here on the right side, moving from the top right and clockwise, we get you covered from day -1 or day -2 and day 0, which is really about planning and basically how you are designing the network that you will then eventually provision in day 1. This is then moving to the orchestration. And then moving to day 2, where you move from provisioning and orchestrating services to a full operational mode, where you really want to monitor, you want to basically track and assure that everything that you provision is performing according to specific expectations, typically in the form of service level agreements, SLAs or SLOs. And if something goes wrong, let's say if based on the service level agreement that you are setting forward with your customer, if there is any deviation according to the way you are monitoring the network, then how you can act on the network in real time in order to mitigate whatever deviation, whatever degradation might happen. And this is what we covered in the optimize here on the upper left corner. Okay, so overall, with Paragon Automation, it's a software suite. We aim to get you covered all across the entire life cycle. So basically taking the classic EMS, NMS approach, right, with FCAPS functionalities, the typical full and configuration monitoring capabilities, into the automation capability for assuring as well as optimizing and basically mitigating any potential degradations that you may have automatically. So with that said, let me just show you in 4 or 5 slides before we move into the case studies, how we do this with Paragon and how we are different. So number one, when we talk about the very basics of automation, we start with lifecycle management, and particularly we start with device onboarding. So when you really want to deploy a new network, or even if it's a brownfield and you just want to provide new devices, today, if we look at how it is done today, it entails a pretty lengthy process. It could be days, it could be even a week or two. It is primarily manual driven, so it's a lot of human prone or error prone, sorry, because it's human driven. And it really entails a lot of truck rolls, or let's say dispatches of field technicians. How we are actually now doing this with Paragon automation, it is really based on self-guided process, okay, that is fully automated based on a template, based on a service descriptor that you define in day 0. So essentially, when you actually dispatch a field technician, it will actually just use an application based on the cell phone that it will provide a self-guided process that is going to be basically error free in terms of it's not going to be any scripting or command line interface driven, but it's going to be just a step-by-step guided process with an integrated testing itself. So it's going to be some pre-established testing in order to also validate that whatever or whenever the device is fully onboarded, that it has been done according to the service level agreements that you are setting forward, right? So with this, then moving to the next kind of a classic use case is service orchestration. So it's not only that we are providing device onboarding or device lifecycle management, we're actually moving to one level of abstraction above at the service level. So it's not any longer that you are really managing devices. Now you can manage services. And based on service descriptors or service intent plans, you can then define which devices and in what fashion or in what manner you're going to, for example, allocate the routing and the specific, for example, BRFs or specifics of that service to every given or any given device. So we're moving out from the CLI-driven concept into a fully programmable service and model-driven concept, where basically you take templates, you basically use JSON and Jinja transforms in order to move from the service level abstraction down to the network intent and to the network instance abstraction. Okay. So the way we do it very simply is we move you from day 0 design, where basically, as I said, you define a service instance and translate it into a network service instance. Then you move to day 1 provisioning, where you apply that concept, that service template into devices and into specific domains that you really want to configure for that given service. And once this is provisioned, then you map all the telemetry and you map all the collection data sources that you really need to keep a track or to keep an eye on that service. And then you move to day 2, which is fully monitoring and then eventually optimizing and acting if everything happens or something goes wrong. Then another aspect I want to highlight here is how we are using active assurance or active testing and monitoring as part of the monitoring capabilities. So if you think about it, the way we've been monitoring networks over the last decades, it's been primarily based on the concept of telemetry, complemented, if at all, with probe-based systems, which means hardware appliances that had to be deployed around the network, across the network, which were very costly and very difficult to scale out in highly distributed environments. Now, with Paragon, what we are doing is we are embedding in our Juniper gear to start with, but also because it's a software instance that you can also deploy in any compute host environment. What we're doing is we're just deploying this kind of a very lightweight software agents on the network gear. So we turn any network demarcation into a real visible point, of, into a demarcation visibility, so to speak. Okay. So why is this important? Is because, again, when we look at telemetry today, telemetry basically, if we just rely on telemetry and we turn telemetry to be our kind of a visible kind of a crystal ball of what's going on in the network, it is somehow limited to the network infrastructure and how resources are performing. However, this is not enough. If we actually break down the network in 3 layers. So let's make it simple. I'm not going to use the kind of the OSI 7-layer model, but I'm going to make it simpler, and I'm going just to use 3 layers. Say the first layer is the network infrastructure itself, is really related to how devices and connections are performing. This is the first one here on the top. Then we may say there is a second layer on how devices are configured in order to deliver some or specific services. And finally, there is one layer on top, which is really related to the end-to-end paths and policies that need to really be in place in order to truly enable those services to reach out the end customers, right? Now, with telemetry, basically, we get a good coverage of how devices and connections are performing. So we really understand how resources are performing in terms of whether they are overutilized, whether there is a link congestion, whether there is a CPU overload. That's totally covered with telemetry. However, whether devices and services are configured properly to deliver specific services or not, this is something telemetry cannot tell me. I'm going to give you a data point here. Based on our first-hand experience, but also contrasted with industry reports, what we see is that up to 50% of quality of service degradations affecting end users are related to misconfigurations, which means are not related to resource congestions or resource issues, so to speak, or network device issues, but really how those devices are configured. So the beauty or the good news about this is that by looking at how devices are configured, and you can do that with active testing, right? And this is why active testing really will allow you to fully validate how devices are configured and how the end-to-end paths and policies are performing. So by actually having that capability and using an orchestrator, you can run out, or basically you can uncover misconfigurations, and then you can re-provision those configurations or misconfigurations on the fly with an orchestrator. So eventually, with automation, you can remove up to 50% of the issues by just having the right orchestration or the right orchestrator in place. Okay. So again, active assurance complements telemetry in order to give you visibility beyond the network infrastructure itself. And last but not least, we also cover things like network security, or what we call the network trust, which is really about how you are really ensuring that things like compliance and configuration management are properly laid down. Things like integrity, validating that you are running the right or the proper software release, that you are not reaching end of life for that software release on that device, that there are any potential bugs that you may need to upgrade to the next software release or next software packages, and so on. So we turn this to be a more deterministic way to measure the trustworthiness of your infrastructure and your network eventually. All right, so with that said, essentially we get you covered with this based on the Paragon Automation Suite. As I said, is meant to be multi-vendor. So It's primarily, I would say, seamlessly integrated with Juniper gear, but we are really evolving it and making it truly multi-vendor by the use of programmable standard-based APIs, right? Things like netconf or YANC models or even OpenConfig allow us really to become truly multi-vendor as we are really moving into a more programmable network infrastructure. So all in all, Paragon is a UI-driven software that it's simple to use, it's friendly to use, and it's based on use cases. It's very highly programmable, so it allows you really to integrate northbound to any of your existing OSS tools, but also it is pretty flexible southbound, as I said, with API-based methodologies, right? In order to retrieve telemetry, in order to act on the network with PCE or LSP standards, and so on. So moving on, I just want now to change gears a little bit and show you some practical use cases with some case studies, okay? So hopefully now I can give you some color on what I've been explaining so far in terms of use cases I showed you before in terms of active testing, for example, service provisioning. So I'm going to give you hopefully a bit more color on some examples. So, but to start with, let me just touch again on the different building blocks, the different stages that we cover across the entire life cycle. As I said, we get you covered from day -N or day -1 or 2 and day 0, which is really about planning. And then we are moving you across the orchestration or service provisioning, things like lifecycle management for device, but then moving into intent-based service abstraction. Then we get you in day 2 operations for monitoring and assuring that services are running the way you are expecting and the way you are defining across service level agreements, as we said before. And you do this with the trust and compliance capability and active assurance, which I'm going to touch upon in the next few minutes. And finally, the optimization, which is really primarily based on the concept of traffic engineering, right? As well as the concept of controller or SDN controller, but also evolving to things like closed loop orchestration and remediation, okay? So just walking through very briefly on each of these different stages. When we talk about planning, this is really about the capability now with Paragon for you to, number one, take a snapshot of the runtime environment. So you take a snapshot of what's going on right now in the network. So you get the runtime environment, and that snapshot, you can bring it offline at any given moment. And once you bring it offline, then you can start simulating what if scenarios. So for example, say you want to understand if you're running into any capacity constraints, then you can simulate the scenarios. What if you, for example, scale out or increase capacity here or there? What if you constrain, on the contrary, capacity on other domains? So then you can learn, you can really see by simulating those scenarios how the network will react, so you can plan accordingly. So eventually, when you want to, move into a productive environment with the new kind of design, you have already done a full validation through simulations. So that would be planning. Then lifecycle management. I already touched on how easy now you can onboard a new device. Again, self-guided, fully automated in order to be, basically human-free or kind of error-free through the way or through the automating of methods of procedures, for example. So that gives you, a pretty solid day 1 foundation on how you are onboarding a device. And moving on, you can move it to the service abstraction level with the orchestration. As I said before, this is something that we already introduced. This is really about introducing the concept of service modeling, with the kind of a service instance, and then transforming that service instance, which is pretty much driven from IT tools, like, for example, the likes of ServiceNow and so on, down to the network instance that you really need to lay down or kind of lay out in the network environment. That transform, so the way you move from this service instance down to the network instance, is really where it makes service orchestration truly valuable, because it really allows you to translate high-level concept of service, like, for example, here's my layer 3 VPN, here's my EVPN or whatever, down to the to the specifics on how you configure every single element, network element, network device that is related to that service. Then we get you covered on the network observability. As I said, this is really about not only collecting telemetry. Telemetry gives you a lot of visibility, and we stick to it. It gives you a lot of insights of what's going on from a network infrastructure perspective. But as I said before, we need to complement that with something else. Why? Because it's not enough to look at the network infrastructure. We really need to understand how devices are configured in order to deliver specific services. And that kind of a configuration layer is something that telemetry won't tell you. A network element won't ever tell you whether the running config that it's running is the right one or the wrong one. So you really need to do something else. And that something else is actually using active testing. What is active testing? Is the capability for you to inject synthetic traffic on the data plane of the network. So to emulate services from layer 2 up to layer 7 in the OSI model, right? In a way that it can give you relevant KPIs, key performance indicators or metrics that are really close to the customer experience. So this could be things like transport metrics, latency, and packet loss, basic ones, but it could be also it could be things like application-based metrics, like, for example, HTTP, HTTPS response times, or first time received, or over-the-top playback rate, and so on, right? So then you can really learn, you can get close to the end customer perspective. And last but not least, network optimization, right? With network optimization is once we learn how the network is performing, right, both from telemetry as well as from active testing, then we can have the network act and remediate, for example, specific anomalies that we may actually detect or run across. So that could be, for example, things like capacity congestion or leak congestion. It could be latency that maybe for some reasons you get some kind of a high latency over one link, and then you just need to kind of redirect traffic using other links. This is really with the concept of traffic engineering, right? And then the proper data sources that we are collecting, then we can actually improve and we can optimize this properly. Okay. All right. So now, just moving to for the next, I would say 10 minutes, I'm going to just focus on 2 specific case studies or examples. The number one is going to be what we call automated assurance, which is really about using the concept of automation or network automation, but primarily driven with the concept of augmented assurance with active testing. So I'm going to cover specifically the day 2 use case here in the circle, right? And I'm going to basically do it with the concept of what we call automated assurance with the service orchestration using the fully integrated active testing. So in order to show you the concept, here's where, for example, at the time we provision a new service, say we have an SDN controller that from a service order request here on the top, it will basically dictate to an orchestrator in between, it could be any orchestrator, to provision a new device. For example, because it's SDN based, software-defined networking based, let's assume it just software instance that you just spin up as a way of, for example, as a BNF or as a container, right? So the orchestrator then, based on the service order request, will then attempt to provision, for example, that device. It could be a customer premises end device by just provisioning the right BNF infrastructure, for example, in an NFVI architecture, and then it will provision the right resources with the right configuration for that device to be fully configured for a given service. At the same time, and here's the concept, what the orchestrator will do, it will actually instruct how we really want to validate, how we really want to test that device as part of the service descriptor, right? So it's not only that that device is going to be, for example, tied to a VRF, or it's going to have an IP address, and it's going to sit on a VPN, but also as part of that service descriptor, we're going to tell in that service descriptor how to test that device, for example, from a test agent that is somewhere in the network down to that device using, for example, standard-based methodologies like TWAM or RFC XYZ in order to, for example, just check things like latency, packet loss, or even things like throughput. So once this is really provisioned as part of the service provisioning process, then we're going to start a test as part of the day one provisioning. And that test is going to provide some metrics that we call adverse certificate, which is an exhaustive test that you perform in day one as you provision that service or that new device, that will actually provide this adverse certificate as a benchmark on how that device has been provisioned in day one from a customer perspective. So then you can basically have it benchmark in day one, and anything that deviates from that validation, it's going to be very easy to spot, and it's going to be easy to actually identify as a delta. Once this is really done, then you move to a 24/7 monitoring capability for day two. Okay, so with this concept in mind, let me just show you a real example. This is actually in a tier one operator here in Europe, where basically by using the concept of service orchestration and testing, we get you covered across day one and day two. Here's how. So as I said, in day one, we just use the orchestrator in a fully automated way to provision new devices or new services on the fly. So say I have a new customer branch office, I need to provision a new CPE device, I use the orchestrator, and bam, I just deploy that new device. As part of that provisioning, and still as in day one, I use an active test that is really running as part of the service model or the service descriptor in order to validate that that branch, that customer branch office has been provisioned properly. And then I have, as I said, a benchmark. I have like a golden reference that I know this will be used in the future. Then we move to day two, right? And in day two, I keep an eye on a 24/7 fashion using telemetry as well as active monitoring. And at one point, something goes wrong. At one point, I get like an alert or I get a threshold crossing event. That basically tells me there is a degradation from an end customer perspective. So what then the orchestrator does? So when we receive that alert, we actually feed that alert into the orchestrator. And the orchestrator, the first thing it checks is whether the runtime config, the config is running at runtime, is the same config we were running in day one when we fully validated that device was onboarded properly or that service was onboarded properly. If there is a deviation, if runtime is not the same as day one config, then the orchestrator may attempt to reprovision the service as per config one or config day one configuration. Remember, as I said before, up to 50% of issues affecting end users today are related to misconfigurations. So by just reprovisioning the config or the day one config, you may actually have the potential up to 50% to remove any incidents. So again, 50% of the chances you will just remove that problem. But it could be that this is the third scenario, the third case, that you run into an issue. Let's say that there is a service quality degradation, that at that time the orchestrator checks whether the runtime and the day one config are the same. And if they are the same, then you know it's nothing to do with a misconfiguration. It is then rather related to a real network issue. Here's where we can also use active testing to troubleshoot, to really help you troubleshoot in order to actually give you two things. Number one, to really segment or sectionalize where the problem is occurring, right? So where exactly in the end-to-end path, it is really where I'm having any problems or any degradations. And this is really very suitable with active testing because we are injecting a packet that is traveling all the way across the path. So then you can easily pinpoint where the congestion could be. And the second thing that active testing gives you is the root cause analysis as well. So not only you can identify where exactly the problem is occurring, but also why it is occurring. Is it, for example, a packet loss because there is a tail drop issue? For example, because a PE router is actually losing packets because kind of the queuing mechanism is not optimized for the latency we are experiencing. For example, that could be a root cause analysis. So all in all, what we are saying here is we are using the service orchestrator with embedded active testing in order actually to have a birth certificate validity in day one. So you can then have a config day one benchmark that you can then relate to anything that happens in the future. And we just follow a standard-based methodology to keep an eye and to make sure that you are just fulfilling the service level agreements and service level objectives with your customer. Okay, so as the business outcome here, and here's quite an important data point I really want to leave behind here today, is what we find is that without active testing or without the embedded capability to use something beyond telemetry, in the operational teams today, up to 60% of the issues are not anticipated or not visible before before the fact. So they're actually coming into the network operating center in the form of a trouble ticket or in the form of a customer incident. But by the time it comes to the desk, it's too late in order to mitigate the impact to the end user. By using active testing embedded with the service orchestration, we can actually address that 60% and be way more preventive. So we can now proactively address up to 80% of network degradations, of end user degradations, or quality of service degradations, before actually the user turns this into a complaint. That's a real case study that we have, not only in this tier one operator, but across the globe. So if time allows, I believe I still have some time, I want to cover another case study, which is not now on the assurance itself, but now on how we can optimize. So again, back to the circle. Now we're going to talk about how we can act on the network in order to mitigate any potential issues that we may run across during the day two operations. So the way we do this is primarily with the concept of traffic engineering. And traffic engineering has been around for quite a few years now. I mean, I would say even almost a decade. And this is really fundamentally based on things developed in the MPLS environment, or things like RSVP concepts with LSPs and TCPs, but also evolving into other domains now, for example, with segment routing. So the beauty about this is that by just learning about the topology and just using telemetry, and in some cases complemented by with active testing, we can learn in real time what's going on, and we can actually act on the network accordingly. So for example, by using the concept of PCE, the Path Computation Engine, and MPLS environments, right? We can actually look at capacity congestions and also do things like path diversity by just proactively acting on the network, as we just learned that specific paths or specific links might be getting congested. So that allows to be more optimal on how you, dimension the capacity of the network. And also it allows you really to be more optimal in the way you are using the resources of the network itself, right? So overall, you can really drive many operating or OpEx savings just by optimizing the network properly. We can also do things like low latency routing. So it's not only that we just look at whether the network and specific links are congested or not, but also we can use things like latency in order to basically enroute traffic from one path to another and from one direction to another, in order eventually to, for example, guarantee end-to-end slices. Now that we are been talking over the last few years on things like 5G network slicing, so that we can guarantee latency buckets for specific services on an end-to-end path. Okay, so these are concepts that we are already deploying across the globe, where, for example, as we said, if we just learn that there is a specific congestion, in this case from R1 to R3, and particularly there is a link congestion between R2 and R3, we actually used the concept of path computation engine. We read it, and then we have the network act and find an alternative routing path before actually that becomes a real problem. All right, so we can use thresholds to and basically adapt the tolerance of those thresholds in order to become more preventive. And eventually, by using things like machine learning, we can even be more predictive as well. Okay, so all in all, again, by using the concept of traffic engineering, we can anticipate and we can become more preventive, and at the same time, as I said, we can be more predictive. So as a business outcome for this particular example, we actually can translate this into TCO savings of up to 27% in the overall network capacity. So again, 27 might not look at huge number, but if you think about how we are dimensioning networks, and particularly how we are actually allowing for a lot of buffering and a lot of, I would say, overcapacity in order to guarantee that things really, work well. Having the capability to optimize and reach up to 27% gains in terms of total cost of ownership, it's something not insignificant. It's quite important. It really translates into a business return eventually. Okay. All right. So just conscious of time, I think I'm going to stop here. Basically, in the closing, I just want to wrap up with the very concept of Juniper Paragon. Again, this is a software suite that runs on top of the network infrastructure. It's primarily and seamlessly integrated with Juniper gear, yes, but it's really evolving to be a truly multi-vendor solution. To the extent we can use API or standard-based API methodologies, southbound as well as northbound, we can turn it into a truly multi-vendor capability. Okay, so again, just to close, is user interface driven, is use case based, so we can just get you covered on specific use cases that you are interested in, so you don't really have to basically get the full suite of all the life cycle of capabilities in order to really run it, but you can just focus on the planning, or you can maybe just want to focus on the assurance or the optimization, and then you can build on that gradually if you wish. Okay, so I think with this, I'm going to stop. I'm going to just check for any questions or maybe comments that we may have from the audience. And otherwise, Katie, over to you.
Thank you very much, Roger. I appreciate that. We do actually have one question that's come in, so let me just grab that now. How does Paragon sit with regards to Apstra, and will there be a consolidation of the two products in the future?
Very good question, and quite timely as well. So we at Juniper actually this year we introduced the concept of AI native kind of networking, where we are really using AI in order to improve the way we do networking. And that's primarily driven the concept. So we at Juniper have three main kind of business units, so to speak. One is anything related to the branch and campus, which is primarily driven today with our Mist portfolio. Very successful with AI. Then we have anything related to data center and cloud, which is Apstra today, with anything related to automation for cloud and data center is Apstra. And finally, for the wide area network, we use Paragon. Now, the question is how these three different concepts, if at all, if they are really different, how they really integrate with each other. And right now, the concept of day two operations, so anything that is really AI enabled is going to be driven by the technology of Mist. So today we see Apstra already with by itself, it has a very nice technology on automating the cloud and data center, but also for day two, it's already leveraging from our success stories with Mist in the branch and campus. So Apstra is already kind of integrating or kind of leveraging from Mist. And eventually Paragon will also leverage day two operations from Mist as well. So to the very question, I would say anything that relates to, again, taking the life cycle of any service, and we go from day negative N or day negative 1 to day 0, and then day 1 for provisioning and day 2. So anything that relates to that it's not day 2 operations, it's going to be specific to any different domain. So Apstra is going to be the right vehicle for day 1 and day 0, anything related to cloud and data center. And Paragon is going to be the right vehicle for anything related to day 0, day negative N, and day 1 for wide area network. Why are these two different, or why these are different is because the wide area network that entails a lot of high sophisticated routing technology, things like BNG, ISIS, or all these kind of highly, I would say, complex ways of how you really operate your network with the routing. This has to be driven by Paragon because it's very specific to this. Apstra will stick to anything. This is really cloud and data center, but day 2, so anything that relates to how we monitor, how we actually ingest telemetry, and how we apply AI, things like machine learning and AI on top, is going to be seamlessly integrated across the board. So Apstra, Paragon, and Mist will actually use the very same technology. This is not yet the case today, right? Because we are evolving, but eventually, say towards the end of this year, even next year, we're going to have a seamlessly integration between the three for day 2 operations. Okay, so hopefully that answers your question. I'm happy to follow up if you need further details on that.
Perfect. Thank you very much for your time today, Roger. I really, really appreciate it. For everyone listening, we have recorded this session, so we'll have that available on our YouTube channel if there's anyone within your business that you think would really benefit from listening and watching this. And yeah, if you have any more questions, then please feel free to contact us and we will be here to help. But thank you again, everyone, for taking time this morning, and we will see you soon.
Thank you very much.